Hello students, welcome to another video of calculus. Today we will start the next chapter, limits. F.Y.B.Sc calculus chapter number 3rd, limits. In this chapter, first of all, we will see the definition of function and some graphs of the function. So the first topic is functions and their graphs. Functions and their graphs. So functions and their graphs. First of all, the definition of function. Definition of function. Function is some rule that assigns each and every element of domain to unique element in codomain that we have seen in the 11th 12th standard. So a function from a set, suppose A to set B, function from a function from a set A to set B is a relation which associates every element of A, that is every element of set A to unique element of set B, unique element of a set B, and it is denoted by function f from A to B. This f is small f. Function f from A to B. Function from a set A to set B is a relation which associates every element of set A to unique element of set B, and it is denoted by function f from A to B. Here this first set is called domain, while the second set is called codomain of the function. So we will write the first set A is called domain, and the second set means B. The second set B is called codomain. It's called codomain of the function. So the definition of the function is a function from a set A to set B is a relation which associates every element of set A to unique element of set B. Suppose this is set A. In particular example, we will take, suppose this is the set of natural number 1, 2, 3, 4, 5 and so on, and the function means a relation from this set A, suppose this is set A, to this suppose set B, such that the function means a relation which associates every element of set A to some unique element in set B. Suppose function f is given by the rule f of x is equals to x itself. Then suppose this A is set of natural number and B is set of, suppose, integers. A is equals to set of natural numbers and B is equal to suppose set of integers. So these are the numbers minus 2, minus 1, 0, 1, 2, 3, 4 and so on. So f of x is equals to x. So function is applied on the elements of domain. Function means a relation from domain to codomain which assigns every element, which associates every element of domain to unique element in codomain. So f of, in particular, if you take the function f of x is equals to x, then f of 1 will become 1, f of 2 will be 2, f of 3 will be 3. So the function assigns every element of domain. The image of 1 is this 1, image of 2 is this 2, image of 3 is 3, image of 4 is 4, and similarly so on. So function is a relation which associates every element of set A, that is every element of domain, to unique element in codomain. So every element of domain must be covered, that is every element of domain must have some image in codomain, but every element in codomain need not be image of some element. So every element of domain must have an image. There is no condition on this codomain, that is every element need not be a image of some element, but every element in domain must have a image in codomain. So this is the definition of function. If we take suppose another example as f of x is equals to x square, then again you will get, suppose set A is equals to here set of integers, and suppose set B is equals to again set of integers, then function f is defined as, this function f is defined as f of x is equals to x square. Then this is the set of integers means suppose this minus 2, minus 1, 0, 1, 2, and so on. This is again the set of integers, suppose minus 1, 0, 1, 2, 3, 4, and so on. Now the image of minus 2 is minus 2, f of x is equals to x square. So f of minus 2 is minus 2 square is plus 4. So image of this minus 2 will be 4, this 4. Now minus 1, so for f of minus 1 minus 1 square is plus 1. Now 0, 0 square is 0, 1 square is again plus 1, 1 square is plus 1, 2 square is 4. Here we get 1 as an image of two numbers, image of minus 1 and 1 is equals to 1, and again here 4 is also image of minus 2 and 2, but the function says that a function from a set A to B is a relation which associates every element of set to unique element in set B. This unique means every element has unique image, that is minus 2 has only one image which is 4, again 2 is to have unique image as 4. This does not mean that the codomain, the element in codomain did not have as an image of two elements. This is not the meaning of this uniqueness. Unique means every element has one and only one image. If we get suppose this set A and this set B, then if we get two images for a single element, then this is not a function. This is not a function. So we need only one image of every element. Minus 2 has one image, unique image is 4, 2 has unique image 4, but this is a function, f of x is equal to x square, but this is not function because every element, that is any element of domain does not have two images. So this is not a function, this is a function. So this is the definition of function. Now we will see the next definition of, which is range of a function. Next definition is range of a function. Range of a function. If a function f from a to b, if a function f from a to b is a function, let f from a to b be a function, then the set R is equals to f of x such that x belongs to A. It's called a range of f. It's called a range of the function f. f from a to b is function, then the set of R, which is the set of all the elements of this codomain, which is a image of some elements in A, it's called range of function. If we see, suppose f of x is equals to x square, then 0, 1, then 4, then 9, then 16, all the elements are images of some elements in domain. So that set which contains, so here 1 is some image of some element, 0 is image of some element, 4 is element of some, 4 is image of some element. Then we find the set which is the images of some elements in domain, images of domain elements in domain, then that set is called range of that function, then that set is called range of that function. Similarly here, 1, this 1 is image of this 1, this 2 is image of this 2, 3 is image of this 3. If we take this set of those elements of codomain which is image of some element in A, then that set is called range of that function. So here the function, if f from A to B is a function, then the set of f of x, this f of x such that x belongs to A is called range of f. This range is subset of codomain, range of f is subset of codomain. Now we will take some examples to find the domain and codomain of the functions. Here we are dealing in real analysis, so that is in real numbers. So for the square root of negative number is complex number, so we will not take the square root of negative number. So first of all, we will take some examples to find the domain and codomain. So the example is, find the natural domain, find the natural domain for each of the following functions, for each of the following functions. First function is f of x is equals to x square plus 2, x square plus 2. Find the natural domain. Natural domain means the domain on which this function can be applied, means the real numbers for which this function can be applied. So f of x is equals to x square. Now f of x is equals to, sorry, x square plus 2. F of x is equals to x square plus 2. This function is defined for any real number, because we know that the square of any real number is real number, and if we add 2 in that square, then we get another real number. So this function f of x is equals to x square plus 2 is defined. So we can find the image of x square plus 2 for any real number. So this x square plus 2 is defined for all real numbers, for all real numbers. So means to find the domains of this given function, we just have to find this function is defined for which real numbers, and that will be the domain. So this function is defined for all real numbers, so the domain of the given function f is R. So the domain of given function, domain of the given function means the set on which this function can be defined. So domain of the given function is R, that is all the elements from minus infinity to plus infinity. So this is the domain. Now the second example is f of x is equals to 1 upon x minus 3, 1 upon x minus 3. Now clearly we can say that 1 upon x minus 3. If we put x is equals to 3, if we put x is equals to 3, then we get 1 upon 3 minus 3 is 0, and 1 upon 0 is infinity. So this function is not defined for x is equals to 3, and this function is defined for all the other elements. Suppose if you take x is equals to 1 and 1 upon 1 minus 3 is minus 2. So minus 1 by 2 will be the image. Then for any real number, this function is defined except for x is equals to 3. This function, the rational function, is not defined whenever the denominator vanishes, that is the denominator goes to 0. So x plus 3 is equals to 0. The function is not defined for x minus 3 is equals to 0, that is for x is equals to 3. So this function is not defined only for x is equals to 3. So given function f of x, which is equals to 1 upon x minus 3, is not defined only at x is equals to 3. Hence the domain will be the domain of f is set of all real numbers except the x is equals to 3. So this domain can be written as x belongs to R such that x is less than 3 and x is greater than 3, or we can write it as minus infinity to 3 union 3 to infinity. This is the domain of given function. Now we will check for the next function. The third function is, suppose f of x is equals to square root of 1 plus 6x. We know that if this 1 plus 6x is a negative number, 1 plus 6x is a negative number, then square root of negative number, to find the square root of negative number is not possible in real numbers. Square root of negative number is not possible in real numbers. That is, to find the square root of negative numbers, we need complex numbers, but we are dealing in real numbers. So this square root of 1 plus 6x is negative, then this function is not defined in real numbers. If the square root of, that is square root of negative number is complex number, that is this function is not defined if this value which is under root, so here 1 plus 6x, if this 1 plus 6x is a negative number, then this function is not defined. So we can find given function f of x, which is equals to square root of 1 plus 6x, is defined if and only if the value which is under root, that is 1 plus 6x, is greater than or equals to 0. If and only if this 1 plus 6x is greater than or equals to 0. If this value is less than 0, means this value is negative, and root of negative number is not possible in real number. So 1 plus 6x is greater or equal 0. That is, the domain of the function is, the domain of the given function is the real numbers such that, or which 1 plus 6x is greater than or equals to 0, which is, we can write x belongs to R such that this 6x is greater or equal minus 1. So x is greater or equal minus 1 by 6. X is greater than or equals to minus 1 by 6. So this can be written as minus 1 by 6 to infinity. The domain of the given function is minus 1 by 6 to infinity. Now we will see the similar example. Suppose the next example is, the fourth example is square root of f of x is equals to square root of x minus 2. Clearly, again, like similar example, the domain of this function will be x minus 2 greater than or equals to 0. This f of x is defined if and only if x minus 2 is greater or equal 0. Therefore, the domain of f will be the real numbers for which x minus 2 is greater than or equals to 0, that is x belongs to R such that x is greater than or equals to 2. So we can write it as 2 to infinity. The domain of the function is 2 to infinity. Now the next example, similar one, f of x is equals to square root of 1 minus x square. 1 minus x square. Similarly, this function is defined if and only if 1 minus x square is greater than or equals to 0. Now 1 minus x square greater than or equals to 0 means this f of x is equals to square root of 1 minus x square is defined if and only if 1 minus x square is greater or equal 0. Therefore, the domain of given function f will be the set of such real numbers for which 1 minus x square is greater than or equals to 0. 1 minus x square greater or equal 0 means x belongs to R such that minus x square is greater or equal minus 1, that is this 1 is greater or equal x square. 1 is greater or equal x square. So this implies x square is equals to either minus 1 and plus 1. So x is in between minus 1 to 1, because x square is greater or equal 1 means x is in between minus 1 to 1, because there are only two possibilities for x. X square is equals to 1, then square root of 1 is either plus 1 or minus 1. So x is in between minus 1 to plus 1. So this is the domain of given function. Now next lecture we will see how to find the range of the function. This is the domain of the function. In the next video we will see the range of the function.